Let's continue looking at some sample problems from section 12.5, and we're now on problem number 20. And in this group of problems it says find the percent of the total area under a normal curve between the given values of z. And in number 20 we have negative 1.74 and negative 1.14. Okay, so this is where drawing the normal curve is quite helpful. So that's why I tried to get you in the habit of doing this from the beginning. Okay, we know that our mean is at 0. Alright, so negative 1.74 and negative 1.14 would be a little closer to the mean. So we're talking about the area we have right here. So what we know is our table gives us the areas out to these particular z-scores. Put z over here just to remind us. So what we need to do is take the area for this z-score minus the area for that z-score to come up with the correct answer. And you'll probably want to have your calculator handy as you do these, since we're working with 4-digit decimal numbers. So again, I'm still using the table 17 on page 671, and so I'm looking at 1.74 because we know it's symmetric, and so that means that the z-score negative 1.74 would have the same area. So that's 0.459. So we have 0.459. That's the area. Let me highlight it in. Okay, so that's our 0.459. Now what we want to do is look up the area for 1.14. Let me change my color. 1.14 is 0.373, and that's going to be this area. Okay, so what we want to do is we want this area that I have the black scribble in. So I need to subtract those. The yellow area minus the green area will give us the scribble area. So we're going to get a 680. Alright, and I believe they told us to give it as a percent. So 0.086 would be 8.6%. So I think it's very important with these, again, to draw the picture, so it tells you whether you're subtracting or you're adding or you're just looking up the number. Okay, so here's our basic drawing in 22. We're going from negative 1.98 to positive 1.02. So this is our area. Again, I'll scribble in the area where we want. I think I'm trying to. Okay, so there's our area we want. So if we look at the table, we want to look up, we're going to have to look up this area and this area, and it looks like this time we're going to need to add. So again, I'll use my colors. So I'm starting with the 1.98, turning back to table 17. 1.98 as 0.476. 0.476. Okay, so this is yellow. 0.476. Okay, now I'll get the green, if I can get my pen to work. Okay, so now we need to figure out this area. So we want to look up 1.02 as a z-score, and I have 0.346. And as we can see, to get the scribbled area, we need to add this time. So we get 0.822, which would give us 82.2%. Okay, now we're looking at the table in reverse. This is a little bit tricky. In 24, we want 4% of the total area to the left of Z. Okay, so again, in 24, I'm going to draw a picture, and I'm kind of going down into 26, but that's okay. All right, here's our 0. We want 4% of the total area, so it's going to be a very small part. So we want to know what Z goes with that. Well, if that part is 4%, that means this part, which is what the table gives us, 0.5 minus 0.04 gives us 0.41. So in the table, we need to find an area as close as we can get to 0.41. So we're kind of doing it in reverse. Before we looked up the z-score and found the area. Now we're looking up the area, and we want to find the associated z-score. And 0.410 is in here, so that's 1.34. And because it's to the left of 0, Z would be negative 1.34. Okay, so this one's a little bit tricky. We're going at it backwards. We're looking at the area. We know the area, looking at that in the table to find the z-score that goes with it. Okay, let's try one more of those. 23% of the total area is to the right of Z. Okay. Here's our... Okay, so we're talking about 23% to the right of Z, remembering that this is 50% to the right of the 0. Okay, so again, we need to subtract that from 0.5. So that's going to be 0.27 is what we need to look up in the table, because our table value is always from the mean out to the z-score. We don't know our z-score. So again, we're going to look up an area, this time of 0.27. So we want to be in the area column and get as close as we can to 0.27. Okay. All right, 0.270. And the z-score with that is 0.74. And this time we are to the right of the mean, so a positive z-score would make sense. Okay, and our last three deal with an application problem. So I think we can draw probably one graph and use it for all of these. So let's hope. All right, this has to do with light bulbs. It says the better light bulb has an average life of 600 hours. So 600 is our X value. Our Z-score for 600 would still be 0. With a standard deviation of 50 hours. So we have X bar is 600. And standard deviation is 50. Okay, and a warehouse buys and installs 10,000 of these bulbs. Find the total number that can be expected to last each amount of time. All right, so we have 10,000 bulbs. Okay, we may have to draw separate ones for each of these. Between 600 and 675 hours. So we're looking for that area, that probability, and then we can figure out the number of bulbs. Now, notice we know the z-score for the bean because 600 minus 600 divided by 50 is 0. We have to figure out the z-score for 675. Our table doesn't include light bulb numbers, but it does include z-scores. So we have to convert everything to a z-score. So just a reminder, we're going to take x minus x bar and divide it by s. So in this case, 675 minus 600 divided by 50. We're going to have 75 divided by 50. I may have to move my 30 down a little bit. Alright, so 75 divided by 50 is 1.50. So I know this is a 1.50. So I just need to look up 1.50 on my table to get the correct area or proportion. 1.50 is 0.433. 1.50, 0.433. And we want to multiply that times 10,000 to figure out how many bulbs. And that's going to move it 4 places to the right. So it looks like I'm getting 4,330 bulbs. Will last between 600 and 675 hours. Okay, between 490 and 720. Okay, I'll just make me another little graph. 600 between 490 and 720. So we're looking for that area. So it looks like we need to compute 2 z-scores. Again, we know the mean. So let's do one for the 490 divided by 50. Okay, 490 minus 600 gives us a negative 110 divided by 50 gives us a negative 2.2. Okay, and our other z-score will be 720 minus 600 divided by 50, which is 120 divided by 50. I have a tendency to want to cancel those out. Okay, so 12 divided by 5, we get 2.4. Okay, so that means on our table we need to look up our 2 z-scores. We'll get one part here and then one part there. So we're going to have to add them. So first of all, negative 2.2, we'll look up 2.2. 2.20 would be 0.486. So this one's 0.486. And that part, I want to look up 2.4. So I had 2.2. Let's go to 2.4. I have 0.492. So I want to add those. 0.486 plus 0.492, and I'm getting 0.978. I think I'll move this to the next page, times our 10,000 would give us 9,780 bulbs would last that long. Okay, and we'll do the very last one.